This is 4-1 day 3 notes. We're going to find the value of f of g prime at the given value of x. Another way to write this is we're finding f of g of x, the composition of two functions. We're taking the derivative of this. Well, to find the derivative of this, we take the derivative of the outside and we leave the inside alone. And then we multiply by the derivative of the inside. This is the chain rule. So multiply derivative of outside, leave inside alone, times the derivative of the inside function. Let's look at the example we have here. F of u equals u to the third plus 1. That's the outside function. And u equals g of x equals square root of x, where x is 4. That's the inside function. So this is the outside. And this function right here is the inside. So we have to take the derivative of the outside times the derivative of the inside. The f prime of u is equal to 3u squared, and then the derivative of 1 is 0. We're going to multiply that times the derivative of g. And the derivative of g is g is the square root of x. The derivative is 1 over 2 square root of x. So we've taken the derivative of each, and I probably should have written it like this. G prime of x is equal to 1 over 2 square root of x. So we've taken the derivative of the outside, f prime of u, times the derivative of the inside, which is g prime. Well, now I have to plug in values. And notice we have 3u squared. Well, that's 3 times the square root of x squared, because u is the same as square root of x. And we're evaluating this at a value of 4. And then times 1 over 2 times the square root of 4. We have, let's see, that is 2. 2 squared is 4. 12 times 1/4, that is a value of 3. What happens if you can write a function as a composite in different ways? Do you get the same derivative each time? The chain rule says you should. Try it with the functions in exercises 39 and 40. In number 40, we have find the derivative if y equals the sine of x squared plus 1 by writing y as a composite with, all right, so letter A, says write it as y equals sine of u plus 1 and let u equals x squared. So that's the inside function. So they're saying the inside function is x squared, and if we would do the composition, we would get that sine of x squared plus 1. So dy, we want dy du times du dx, and that's equal to the cosine of u plus 1 times 2x. And if we do the composition, or not composition, but if we plug x squared in for u, we get cosine of x squared plus 1 times 2x, which is the derivative of this original function. Now in letter B, if we do dy du times du dx, do we get the same thing? In this case, we have the cosine of u, and then multiplied times the derivative of the inside would be 2x. Now u in this case is x squared plus 1. So we get cosine of x squared plus 1 times 2x. And in either case, we get the same exact answer for the derivative.